You're not going to want to miss this episode of the AI Show where we take Azure Cognitive Search to the next level with similarity and scoring that you can tweak to your heart's content. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're going to talk about similarity and scoring in Azure Cognitive Search. I've got a special guest with me. Tell us who you are and what you do, my friend.
Hey Seth and everyone watching. My name is Rauf Marouch. I'm a software engineer in the Azure Cognitive Search team. I've been working in that team for a few years now, mostly working on the relevance part of things, so how we rank documents. And that's what I'm going to be talking about today.
Fantastic. Well, let's dive in, my friend.
So I guess, first of all, Azure Search, I assume most people that are watching this show probably heard about it. If not, Azure Search is a search as a service product on Azure. The idea is that you tell us where your documents are, or you give us your document directly through the push API, and then we're going to provide you with rich full text search capabilities. So first of all, Seth, if you would allow me, what I'm going to do is just to give, one sec, Seth. Let me share.
There's an edit point. It's going to be just fine too, because I'm actually getting your slide. Okay, go.
Cool. All right. So first of all, if you will allow me, I'll the way this presentation, I guess, is set up is, first of all, I'm going to explain how Azure Search works out of the box, right? So what is the process without any developer, let's say, interaction, how it works, how we score documents, and then later on, I'm going to explain how developers can go further and add their own input to the process. So first of all, the information retrieval process in most search engines can be divided into two parts. The indexing, which usually happen asynchronously and is how you get your documents in your search index, and the querying, which is designed to efficiently find documents that are relevant to a specific query. The whole pattern is designed around the assumption that querying needs to be fast since the user are waiting for the results, while indexing is usually not as time sensitive. To achieve this balance, a lot of work is offloaded to be done at indexing time. In the following few steps, I'm going to highlight some of the most important steps for both processes, notably how we process the documents at indexing time and how we created an inverted index. And then once a user emits a query, how we retrieve those documents and how we rank the results. So text processing is probably the most compute-intensive part of the indexing process. It's where we apply lexical analysis on the content to extract what we call tokens from raw text. To achieve that, we use text normalization techniques such as stemming or lemmatization. For example, we can see the term largest here was broken down into both large and largest, which will help increase the recall on queries that search for those terms. For the viewers, recall is the metric we use to measure how good a search engine is at retrieving all the documents that are relevant to a specific query. The process also removes stop words such as this and has, and possessives such as the trailing S on Seattle's. All of those text processing capabilities are available for over 50 languages in Azure Search. You can even create your own custom analyzer using your own set of lexical rules. And we also have APIs for you to test those analyzers or the built-in ones and see how tokenization is done for any text that you give us. Once we've extracted all tokens from all documents, we create what is called an inverted index. An inverted index is data structure that allows the quick identification of matching documents without having to scan through the content for every query. The way this is achieved is by using the tokens we extracted in the lexical analysis phase to be keys for retrieving the list of documents. For example, on the left of this slide, we have the content of 4 documents. And on the right side, we have a subset of the inverted index that would have been created, which contains some of the tokens from those documents, each pointing to a list of IDs of the document that contain them. For example, if we're looking for downtown, we know that document 1, 2, and 3 contains that specific term. At this point, let's imagine we have processed all indexed documents and we have fully created an inverted index with them. Then we receive a search query. For example, in this slide, downtown hotel with pool. So first we apply a lightweight version of the lexical analysis on the search query to extract its token, such as downtown, hotel, and pool. Then we simply travel the position for each token, as we discussed in the inverted index, to get all the matching documents. At this point, we need to decide how we're going to aggregate the result and that depends on how we configure the query. So for example, if you want to be very restrictive, there is a search mode parameter for each search query in Azure Search that you can set to all. This means that you only want to return documents that match all terms. In this case, if you search for downtown hotel pool, that would only be document number 1 because that's the only one that is in all 3 collection of documents. Or if you want to be less restrictive, you can set it to any and say return any document that match any of those terms.
So just to be clear, we don't have to do anything. This is just something that's happening directly in Azure.
That's right. That's exactly right. So everything that I've shown so far, all you need to do is tell us where the document are. If you want to use what we call an indexer for us to go crawl that data and get it into our search index, or if you use the push API and send us those documents, we're going to apply everything. And we actually, even this slide, what we're going to do for the ranking part, even this is applied automatically.
That's cool.
So what ranking is, well, first of all, let's assume that we've now retrieved all the documents that are relevant to a specific query. And now we decide we need to rank them to make sure that the most relevant one are at the top. So to achieve this, we're going to compute a similarity score for each of them. That score is computed token per token, field per field, and is aggregated at each step to generate a final similarity score that ties a document to a specific query. Now, we could discuss at length about the various formula being used to calculate similarity scores, but the most important thing to know is at their base, most of them rely on 2 main variables. First one being the term frequency, which is how often a specific term appears in the text, and it gives us an estimate of how relevant that specific document is to that specific term. And then we have the document frequency, which is within the index, how many documents contain that specific term. That gives us an estimate of how common that term is. The idea being that the more common a term is, the less weight it should have when calculating the score. With just those 2 variables, you get the famous TF-IDF algorithm, which set I'm sure you heard of, and which is simply the term frequency divided by the document frequency. Now, in practice, production systems use more elaborate version of this algorithm. So, for example, here, this is BM25, which looks very complicated, but at its core, what it does is it adds awareness of the document length into the equation and also apply curves to normalize the term frequency. There's a lot of documentation online, either on Wikipedia or even on the Azure documentation website that explains more details how those scores are calculated and how the formula works. Does that make sense, Seth?
Yeah, so this is all just basically standard search, indexing, ranking. This is all just happens just automatically for everybody.
That's completely right. Yes. So as of now, up until this point, we're really using search as a text-based engine, right? Every single decision that we made on either to retrieve a document or how to rank them is based on text values, which works very well as a baseline for most search engine. Now, some of the challenges that we're going to go through in the next couple of slides is that each data set is different, right? And it always makes sense for the developers and domain experts to apply their own knowledge to try to tweak those processes a bit further. And that's how scoring profile works. So, yeah, the idea is really just, your data best. You know what documents your customers are searching for, and you might want to add some input into this. So scoring profiles, the way that works. Here on the screen, this is just an example of an index definition. So far, we've mostly been, like all the examples that I gave so far were where we treat the content as being just one mass of text. In reality, most documents have structure and are comprised of various fields which can be searched on. For example, here we see a document describing a hotel. It has a name, a description, reviews, tags, and also has non-text based fields such as just metadata, location, rating, prices. At its simplest form, scoring profile can be used to tweak how much each of those text fields contribute to the final score. A domain expert could decide that matching a query in the name field is much more important than matching a term in the review section of the documents, right? So using a scoring profile, you can pretty easily just go through, your various fields and give them a relative weights. And this is how we're going to calculate the final score for your document. For example, here, we decided that the name is 5 times as important as the review. So as we define this in the scoring profile, this will take that into consideration.
I see. So this is after it does the normal search index theory stuff. What we can do is we can go through each field in our index, and because obviously highest number wins, and it's ordered by score. And so if you multiply the weight of the name by 5, name is going to be super important.
That's right. That's exactly right. Yes, and name will be, objectively 5 times as important to review because that's how we decided to set it up. And the way you do this, the way you make those decisions in Azure Search is, again, pretty straightforward. We have the scoring profile. On the left, you see the expected JSON profile. If you're using the REST API, you'll notice that the scoring profiles is plural and it expects a collection. That's because you can define multiple of them. And then at the bottom here, you can see this is an example of a URI that you would use to do a search query where you have a scoring profile parameter. That's because at runtime, at query time, you can decide which scoring profile to apply to that specific query.
Which is nice because you could, and sorry to interrupt you, because you can actually switch out depending on who's looking at it by their login property, for example.
That's right. That's right. That's exactly right. And, even like you mentioned, different users might have, different search preferences, but also different scenarios on your website. Maybe somewhere you have, a search just to return product on sales. Maybe you have somewhere which is, promoted product, etc. So you can really define this and create all the scenarios that you want to support. And the way you do this is, again, you just set the weights you want for each field. You can also do this through the portal. There's a neat UX that is available online on the Azure portal. You just select what fields you want, what weights you want, you save that, and you're done. Now, the other way to leverage scoring profile is through functions. The idea is to compute a boosting value using certain non-searchable fields from your index to be multiplied by the original raw similarity score, the one that is text-based, that was produced from your text field. There is 4 types of function that we support. There's the magnitude function that is applied to number fields. For example, let's say you have, your index is a product catalog. You might want highly rated documents to be ranked higher because they're of better quality, and that's what you want to sell on your website. Again, you need to make sure that those functions, the idea is not to sort your result based on a specific number. This is not a sorting algorithm. The idea is to create a boosting function that will slightly nudge the result in the direction that you want. Another way that you can see this is, let's say you have a view count. For each document, you have a field that shows the view count for that specific page. Then you might use this as a metric to say that certain documents are more popular than the others, and you might want to make it easier for your customers to find those documents.
So it's just a number to multiply by the output to make the rank a little bit higher.
That's right. That's exactly right. And we also support what we call freshness. The idea is that, to go back to the article example, let's say you have, you're a news website. It might make sense in your scenario that recent documents are more relevant than the older ones. If someone is searching for the Olympics, then documents about the recent Olympic that were published this week are probably more relevant than Olympic document that dates from a couple of years back. We support distance. So if your website has, restaurant or stores, more closer restaurant might be more appealing to your customers. And finally, we also support tags. The idea behind tags is that you have to manually add metadata to certain document, and you can decide at query time to boost document that contain those tags. So for example, let's say on your website, you tag certain document with a promo tag, then at search time, you might say that, hey, for this week, I want promoted product to be ranked higher. And another very popular way to do this is, let's say you have an intranet search where you have, your whole company is on the same search engine. And let's say someone from the engineering team is searching for documents on that search website, then document tagged as engineering plan might be ranked higher. While on the other side, let's say the legal team is looking for document, and maybe document tagged as legal document might be more relevant for them. So as you mentioned, Seth, so the idea is really just to calculate a boosting value to be multiplied to the score that will be used in the final ranking. And the way you do this is, for each of those function type, you have different values that you have to set, different parameters. So for example, for magnitude, you would set the range of the expected value. For rating, it might be from 1 to 5. And then we're going to translate the value in the metadata for that document using that range and using what we call, what is an interpolation function to get a final boosting score. And that score is simply multiplied to the similarity score. And you can see here we support various different type of scoring function, depending on what scenario you want to exercise. So how this works here in the example, to go back to the hotel example. So, maybe specific document that we're calculating the score for is tagged as a promo. So we're going to multiply the score by 1.5. Maybe it's within the 10-mile range that you established in your scoring profile. So we're going to use the interpolation function to get a specific boosting value from 1.5 to 2. Again, defined by the user. We aggregate all those values to get the final boosting score, and that's what we're going to be using to calculate the similarity value for that specific document. And this is how you define it. Again, pretty straightforward. It's the same way as you would do for the weights. In this specific scoring profile, you can see that we support both text weight, so field weight, and also we have the function that were defined, such as distance and tag, or you can use the portal to define such function. Again, using the UX should be pretty straightforward.
So as I'm looking at this, you have the option to not only add weights for fields, but you can also add functions to things that are like metadata of the fields, like tag and distance. And then obviously the other one, weighting, it just multiplies numbers again. But this is pretty cool.
Yeah, it's pretty cool. And we've had customers being very, very creative in the way they use this. We have customers running A/B testing. They create multiple scoring profile, and then they'll just test them in the wild, and then gather various metrics to see how successful they are, how one behave versus the other, what one gives the best click-through rating, for example. We've had customers who go really all in and use machine learning techniques to try to calculate those weights and see, again, which one makes sense based on label data that they have that they could run against. And to be honest, Seth, if you would allow me, we're very curious to hear how our customers are using or how they're taking care of the relevance aspect of their website. So if any customers out there is really want to contact us, talk about this, like we're super curious to see how we can improve our processes, what tools we can expose to you to try to make that whole process easier. So please feel free to send us an email at azuresearchrelevance@microsoft.com. We'd be happy to get in touch with you and just go from there.
Well, this has been amazing. I've learned a lot. I thought I knew a lot about Azure Cognitive Search. It turns out all I knew was all the way up until it gets in the index. I had no idea you could do all this amazing stuff. Thank you so much for spending some time with us.
Yes, of course, Seth. Thanks for giving me your time.
Again, thank you so much for watching me learning all about similarity and scoring on Azure Cognitive Search here on the AI Show. Make sure you tune in, and we'll see you next time. Take care.